Next up, we're going to have Riccardo. It was Mo, Mark, and Anne had to share a slide deck, but Riccardo gets one all of his own. So he's going to be talking about portal self-service and giving us all the details on that. Thank you.
Thank you. Hello, good afternoon. I'm Riccardo Verzeni. I'm head of software at LINX, and I'm here to talk about the portal self-service recent developments from a backend view perspective. Tomorrow, in the product update, Mike will cover from user perspective in portal. And so basically, the portal self-service revolves around one system, which is called the order management system, which has been fully released only recently with a bunch of new order form, which we released a few weeks ago. Then I'm just going to cover the main high-level design, and then I'm going to deep dive a little bit on the main components. Then I'm going to talk about a little bit of the current utilization of the order management system, and then the future developments which we are planning for this system. So starting from the order management system, so here you have a general kind of schema of the concept of the order management system. So you have 4 main stages for processing of an order. So obviously you start from the store where the customer member effectively requests an order. Then you move to the inventory, and where basically the order has been recorded in a ticketing system, and also initial services are created on the business support system and in the operating support system, which the difference between the two is one contains the business-related information of the service, the other one contains the technical-related informations. And then we move to the quality assurance, where basically we verify that what actually we created in our system initially is correct, and then we are ready to go towards the provisioning. And in the provisioning phase, we basically have our network configuration automation platform that takes the basically the information from the OSS and push them in our network. And obviously there is also interaction with the ticketing system because it gets updated while the provisioning is progressing. And then of course at the end you can repeat the cycle. But more in details, so you have basically here a graph. I don't know how much you can see. Actually, I don't know if you can point. Yes. So basically, the main kind of core of the order management system. So you can see in the previous one is kind of the glue in between all the stages. Is this part here, which is basically a messaging queue, which has different queues named after different stages. So the inventory, quality assurance, and provisioning, and then a consumer here that, or consumers that basically run some Python scripts that perform some, basically consumes the data that they receive from the message in the queue, and then they interact with the different impacted systems, which were kind of mentioned on a high level in this graph. And then basically move the message, so the order to the next queue to be processed again, and different system get kind of impacted by it. Everything starts from the portal order forms, and that basically creates via API an entry in the order module in CRM, which is our business support system, Sugar CRM. And then obviously sends a message as well to the queue to bootstrap the process on the inventory. And yeah, that's pretty much it. This is kind of the high level of the system. Now if you go on the main components, as I mentioned, as you can see in the previous slide, kind of the first point is really CRM order module. So we created basically the order entity in our BSS. It's composed by 3 main elements. So the LINX order itself, which contains the user information and the overall order status. The order items that actually contains the actual information on what is being ordering, so the service type and the action that we need to do on that. Then the status, of course, of each order item, and detailed used by the messaging queue consumers, which basically has information about what actually was ordered by the user. And then order logs, which have internal debugging informations for our internal use, and also user communication information, which are the very same that are exposed on portal by API. So here, just a very simple diagram to explain the relationships between the various tables. So you have one-to-many relationship between orders and order items, and then you have one-to-many relationship between order logs, and then one-to-zero or many relationship, because you can have basically order logs that just are referred to the orders and not to the order items. And the next component is the orders API module. So we have an internal multi-purpose API called LINX API or Vanilla API. We created a module to interact with all these different tables. So as you can see here, it's one for read and write on orders, one from read and update, basically order items. Update the orders, and then one for the order items to actually read them. And for read and update order logs. We also can update order items directly, patching basically the orders, because the order items actually are exposed with the orders itself. So these API basically manage all the interaction with orders, order items, order logs, and all the other involved systems. And they work in parallel with the service API module, which once basically the order is processed and past the inventory stage, there are actual services that exist. So we basically create them and then update them by the service API module, which is another module in our APIs. Then the NCA action API module, which is basically the API that handles the automation part, which I'll cover later, and the Despro API, which is Despro is our ticketing system. So these are third-party APIs that we use to create tickets, update them, and so on. Right, so this is an example of the orders API module, the base order structure example. So that would be, so if you basically get an order, you get basically this. So you can see, I mean, it's very small there, but you see basically the name of the order, the status, who requested it, right? And in this case, you also have a sub-customer section, because this was on a reseller sub-customer, sorry, a reseller example. In a direct member, you wouldn't have the sub-customer session. Then you have other details like the Despro ticket ID and so on and so on. And then you have items. And the items, you can see a breakdown here. These are actually the order items related to the order. And as you can see here, this one is an order for a new connection. So it's a connection port unit on a reseller port on behalf of a sub-customer, basically. And this contains all the information needed to actually deploy that service. And then we can move on to the order processor. So the order processor it basically is a Python script, and it's run by the consumers of the messaging queue. You can see here an example of the structure of that Python application. And there are 3 queues to serve: inventory, quality assurance, and provisioning. So you can see there should be here. So inventory, quality assurance, and provisioning. So you have, for each queue, there is one main class, which is handling the messages in the queue. The steps for each are the same, so they process all order items and change the status of the order, fail if any of the items was processed correctly, otherwise they move it to the next queue. And for each order item, there is a separate handler, which you can see here, which is repeated for all of them. So reseller peering, new, I think, which handles basically the actual order item, the steps that need to be done there. And each order item is a combination of a service type and an action. So in this case, reseller pairing unit and a new one. And the provisioning part, so by the way, this one, the processor actually processes every queue, but then when you reach the order provisioning part, we moved towards the automation platform, which was already there. So the automation platform used for the OMS is NCA 2.0, which is the second generation of LINX network configuration automation tool. And it was designed specifically for member-related, low-risk, unsupervised config merge. So as you can see from the graph, it looks quite familiar with the original one. That's because we're kind of reusing exactly the same infrastructure. So it's, again, a messaging queue, the very same one. And we have consumers at the end of the messaging queue. We don't have specific queues, like for the OMS, that we move the messages from one to another. We just have some queues, and then the request goes in, and then whatever consumer picks it up, then process it. But the concept is very similar. And the difference, of course, is that the vanilla API in this case is not the order module, but is the NCA action API module. So what happens basically that the data that belongs to that order item, the details, actually get used to create an action or an NCA action in the API that contains the necessary technical information for make the deployment. They go in the queue, they get processed, and then by a Napalm library, we perform they get matched with the right config snippet templates. The config snippet templates get expanded and then gets pushed to the switches. Once that's done, the network config repository is updated with a git commit, keeping track of the changes and also keep the system consistent with the other automation platform, make sure that they don't go out of sync, and also calls the vanilla API, in this case the service APIs, to update technical service inventory, which is the operation support system at LINX, so the database that stores all the technical admin status of all the services. And yeah, that's pretty much it. If we move on the portal side, so basically that's what the user sees. So this will be very, very high level. Will be more in details tomorrow, I guess, from Mike's presentation. But this is just saying that the orders are exposed to the end user via portal orders page, which you can see here, and they're listed here with the overall status. This is powered by the orders API module, which were showed before. You can click on view order, and you get additional information which are exposed related to the order item. As you can see here, you have a closed user group and a closed user group unit, which basically needs to be ordered together. And you also have order logs underneath. You can expand them, and that will have the user communication, which I was mentioning before. And that's pretty much it for the portal side. And then you also have orders tickets, which in this case represent the interface mostly used by NOC or internally to check how the order is progressing. So at the moment, a lot of the orders, so all the orders that require some manual step, they automatically get set as manual processing order, meaning that the OMS kind of had a label on it, and means everything that basically have been presented so far gets put aside, and then the ticket just gets created and NOC and sales processed normally. So when that happens, basically the OMS just creates the ticket in the sales queue, as you can see here, and that's it. From that point on, just goes on normally, as if the OMS wasn't involved or minimally involved. But when actually the order is possible to be processed by a self-service, meaning that everything can be done end-to-end by the system itself, then actually obviously the services are already created, so there is no point sending on the sales queue. They immediately are sent to the provisioning queue, but also there's nothing needs to be done for the provisioning. So basically what happens is that the tickets are in the provisioning queue, and then the OMS keeps updating the ticket with automating provisioning main progresses. as you can see here, and also adds more verbose notes for knock. So some of these are actually, so the gray ones are notes for knock, so the user doesn't see that. So I mean the end customer, and the blue ones are the one actually that are updates to the actual ticket for the user. And it also changes the status of the ticket according to the provisioning status. So, for instance, there is an error awaiting agent, or if it's completed, well then completed. And all of these basically is kind of managed by the processor of the consumer of the queue that we showed before. And also small details. So obviously to give to sales visibility of what's happening, we also create a read-only ticket for queue when it's a self-service order, so they can have a look on how many are developed. Are provisioned basically and sold. That was it for the main components. If we go on current utilization, so as I mentioned, we fully released the system quite recently, but we already had this actually production. We had a few order in, so you can see the first two, there was some issues, so they ended up with error. But this is also handled by the system, so basically when that happens, basically the ticket gets updated, knock is notified, so they go in and fix it manually. Most of them here were manual processing, so they were kind of provisioned normally, manually by the user. But we had like two self-service orders which were completed here, where basically no one had to do anything on them. And if we pick one, obviously I blurred the part for anonymization. You can see basically this is CRM where you have basically the order. This is the representation of the order item associated to it. In this case was a new connection being requested, and then you can see the order logs with the various updates, logging item that were created. So first in inventory stage, then the quality assurance, and then the provisioning. And you can see the messages here updating the status of the progress. And that's it for current utilization. Obviously, we are expecting obviously the number to increase, but so far so good. On future developments, so as I mentioned, so as you could see as well, a lot of those orders were going on manual processing, which is not ideal, because ideally we want to try to do as much as possible of the order automatically and then just do the manual part separately. And so because of that, we will improve the OMS to pause when a manual step manual step or steps are needed, and restart when triggered by the NGUI, so which is the Operation Support System UI. So meaning if a physical port is requested with, I don't know, a PVLAN, then the part that is actually plugging in the physical port, that is kind of the order is paused until that is done. But once that's done, NOC can actually go on NGUI and say, okay, now that's done. And then from that moment on, the orders can be picked up again by the system, and then everything else can be done automatically. So that basically would be kind of one of the first immediate improvement we're thinking on to do next year. And another one, of course, is integration with the X API. So you could see from the first slide on the store, you had Portal and X API. Currently, it's not like that, but it can be integrated with OMS with minimal modification, X API. That's because all is required is to generate the same order inputs as Portal does for OMS. And at that point, obviously, OMS will just do it the same way that does it for Portal. And this will standardize LINX user experience, ordering a service either via Portal or X API. Finally, another improvement of future development we're looking for is asynchronous order item processing. At the moment, really, you can only order as kind of one type of service at a time. But there is no reason why we shouldn't be able to order multiple ones. So you just go on the portal and then select multiple services you want in one go. But obviously, at the moment, unfortunately, the order moves through the queues as a unit. And ideally, you want the order items to do that separately. And that would require some additional redesign, but that's basically something we're going to look towards too. And that's it. So thank you very much. And if you have any questions, I will be very glad to answer them.
Okay. Any questions for Riccardo? Okay.
I think there's one.
Oh, we've got one over here. Oh.
Thank you. Did you do the same for in reverse for decommissioning?
Sorry, I couldn't quite get that.
For decommissioning, do you essentially do the same process?
For
or is it
decommissioning, meaning like canceling an existing service?
Exactly, yeah.
Not at the moment. The moment we actually started with new services and we moved to editing services. We launched editing services for reseller connections, and we are adding editing services for the new order forms that we just launched recently for the other services. But first quarter next year, we will aim for finishing the editing, including the cancellation as well.
Perfect, thank you.
Okay, thank you very much.
There's another one.
Do we have a question down here?
Hi, I actually used your self-service portal and got one of the totally automatic, auto-provisioned bandwidth change orders, and that was very smooth. Couple of questions. One is there any check of success in terms of when it goes to the provisioning system so that you check that you can ping the member before and after and make sure nothing's broken?
Yeah, I didn't actually cover too much in details. We have basically depending on the change, we have like required automatic quarantine testing, and then obviously, if you do the quarantine testing, I mean, you wouldn't be able to deploy it unless that succeeds, and that's sort of a check. And then at the end, basically, each change that happens via the automation platform is, I mean, the configuration change merge needs to be successful in order for the job to succeed, and therefore for the order to be in a completed status. If that provisioning part should fail, then the entire order should be marked as an error. So there is an inbuilt check from our automation platform. Basically. Okay,
but I've had manual orders in the past where somebody's applied configuration and it's looked okay, but actually my port has just stopped forwarding traffic. So is there any tests that the port is still forwarding traffic?
So, I mean, if the configuration change was applied successfully, but the traffic wasn't working anymore, then I guess that's something that needs to be discussed between software and network engineering, trying to figure out what really caused that. But if you open a ticket with NOC, and I'll be glad actually to use that as a use case to discuss internally.
Okay. Also, is there any chance of an indication of what kind of disruption for instance, port speed change might make in terms of, is there a few seconds of traffic disruption, or should be a completely hitless operation? So
all the changes that we kind of implemented for editing should really be on kind of the service basis, meaning that no traffic should be interrupted unless the user says. So there is actually a part on the portal that says this will cause basically your service to go down. Are you really sure? Are you ready to do it now? And basically, ideally, so any user shouldn't really be surprised so it should be a conscious decision basically when the traffic is interrupted.
Great. Okay. Perfect. Thank you.
You're welcome.
Thank you very much. Any last questions? Okay. Thank you, Riccardo.
Thank you.